Thank you, everybody, for attending the research results presentation for evaluation of traffic flow analysis and road user cost tools applied to work zones. Dr. Jacqueline Jenkins of Cleveland State University and Dr. Deborah McAvoy of Ohio University will be presenting today. I urge you, if you're joining us online, to please mute your phones pressing *6 and keep them muted until the end of the call when we open it up for questions. You may also use the chat pod online to type out any questions during the presentation. The PowerPoint is available online above the chat pod for you to download immediately, and it will also be available after the results presentation on the research website probably within a couple weeks. And with that, I'll turn it over to Dr. Jenkins.
Thank you very much. This project, the evaluation of traffic flow analysis and road user cost tools applied to work zones, was initiated because ODOT was using a program called QUEWZ, which they needed to replace. QUEWZ is no longer supported by the developer, and it is not compatible with our current versions of Windows, so hence the need. Let me see here. All right. So where QUEWZ pops up for ODOT is in two documents. The first is a traffic engineering manual. QUEWZ is identified as an appropriate piece of software to look at queue lengths occurring in work zones with lane closures. A queue length analysis is required when looking for an exemption for a proposed lane closure that violates the permitted lane closure map. Okay? Let me see here. There we go. And within that traffic engineering manual, the procedure includes not only the use of QUEWZ, but an existing queue calculation worksheet for freeway work zones. The other document of interest for this project was the Innovative Contracting Manual. It includes procedures for looking at road user costs. One of those procedures specifically looks at work zones with lane closures, which a capacity estimate is generated using the QUEWZ software, and then a work zone user cost calculation spreadsheet is used to find the road user cost. So the scope of this project was to basically look at QUEWZ and these two spreadsheets and then develop either an enhancement or a replacement to the use of QUEWZ. So generally speaking, the description of research had several main tasks. We did a literature review, which included a review of a variety of software tools, a variety of research done on work zone capacity, research done on the value of time, the economic value of time, as well as the cost of lane closures and lane shifts. We also used some of that information out of the literature review to put together a survey to develop some user specifications. And we used the district work zone traffic managers to provide us some feedback as to what they needed in a tool to do these two types of analysis. We also did a brief survey of state transportation agencies to see what they were using. And originally the project was to look at an existing tool that would fit ODOT's needs. However, as the project progressed, we ended up basically reevaluating, looking at those tools and extracting components that ODOT was interested in and developing, instead of an upgrade or enhancement, 2 new tools. In addition, we did some data collection out in the field for 2 construction seasons and an effort to calibrate and validate the queuing analysis tool. So the rest of the presentation is going to be focused on these 2 tools and their use within the current procedures that we have in the traffic engineering manual and the innovative contracting manual, as these two tools should replace the use of QUEWZ and the existing two spreadsheets. So the queuing analysis tool was developed so that it could be displayed on a single 8.5 by 11 sheet of paper, as you see currently on the slide. It does a deterministic queuing analysis for 24 consecutive 1-hour intervals. I understand there's a lot of information on the screen, so we're going to break this down into individual blocks, look at each block and the type of analysis that it does, and then go to the calibration. So the first block is a project information block, followed by a traffic volume data block, a pre-lane closure condition block, a lane closure condition block, which is actually in the work zone, with some queue information in a queue information block, and then the block that contains the actual analysis, and finally an output graph. So we're going to look at each of these individually. The project information block essentially is just a place to record what the project is that you're working on, what is the management of traffic scenario that you are trying to analyze, and who you are. Pretty straightforward. The traffic volume data block has the functionality to use either hourly or AADT information. If hourly is selected, basically all of the white cells are where you can add data into the spreadsheet. So if hourly is selected, what allows the user then to input estimated hourly volumes for each of the 24 hours. The user then also selects a base truck percentage, but also has the option to vary that percentage by hour, which allows you as a user to have that flexibility to be sensitive to hours where you have higher truck percentages and hours where you have lower truck percentages. It allows the adjustment either up or down. We also have an input for a diversion threshold. Currently, ODOT uses a threshold of 1,000 vehicles per hour. So that is our default in our spreadsheet right now, but it can be adjusted for future use should that change. And then in the diversion percent over threshold column, that would be the percent of traffic over that threshold that would divert. Again, that input is allowed per hour, so it can change over time. So the traffic volume data block also allows ADT information. So if ADT is selected, you are then asked for a ADT value, an hourly distribution, and a direction of travel. There is a second sheet not shown here in the spreadsheet, in the workbook, sorry, that is for all the ADT information. It allows for a user-defined ADT data set as well as standard data sets for rural or urban based on ODOT data. Once those ADT value and hourly distribution and direction of travel are defined, then as you can see, all the grayed out columns for estimated hourly volumes and ADT information is gone because those are automatically populated based on the ADT value that's entered and the distribution. The user then has the base truck percentage to enter and any adjustment for each hour of the 24-hour period. Just like the hourly traffic volume data, if ADT is selected, again a diversion threshold of 1,000 is the default but can be adjusted, and the percent over threshold are entered by the user. When all of that is done, whether you're in hourly or ADT, what you are getting out of all of that is a volume for analysis in passenger car per hour and a work zone volume in passenger car per hour. which brings us to the pre-lane closure condition block. This is based on the 2010 Highway Capacity Manual methodology for basic freeway segments. So it is a standard formulation that comes out of the HCM, and it looks at the number of lanes, the type of terrain, uses a base free flow speed, and then applies adjustments based on lane width, lateral clearance, ramp density. We've also included an adjustment by the user, which can be used to change the speed within the work zone to reflect either a reduced speed limit, or if the user has a good data set of speed, to adjust it to those observed speeds. And the output from that is a freeway segment capacity in a pre-lane closure condition. So this could be a long-term work zone without a lane closure, or a non-work zone area as a pre-lane closure condition. The lane closure condition block then is used to identify the conditions during the actual lane closure. And this is again based on the 2010 Highway Capacity Manual. This is the adjustment for work zone capacity. It uses a base capacity of 1,600 and applies adjustments for the work intensity. And that can be a collection of the number of vehicles, the number of workers, the closeness of the activity to the lanes. I also included a calibration of base capacity, which I'll touch upon a little bit later when we talk about calibration using the field data. And the other entries is the number of lanes that are open and a adjustment for ramps. And these are specifically for on-ramps within the taper area of the lane closure. And this is basically due to the interaction of oncoming vehicles into the main lane of open traffic. Okay? When these are selected in the, or entered into the deterministic Q analysis block, they can be done for each hour. So you can actually have one lane closed followed by a double lane closure that then backs out to a single lane closure over a period of time. So you're actually looking at multiple management of traffic scenarios within one analysis here. So all of that information is then gathered within the determinate Q analysis block. The demand information comes from our hourly or ADT volumes and adjustments. The supply is basically what's happening in the pre-lane closure and lane closure condition. And then we do a Q analysis. And this is a deterministic Q analysis. It's basically a count of the number of vehicles that are coming in as compared to the number of vehicles that are being serviced by the work zone. And we're just going to zoom in on the analysis block to show what is actually calculated here is the size of the queue, and that is given in the number of passenger cars. Those are the folks all waiting to go through the work zone. And the length of that queue, so we're just making an adjustment from the number of vehicles in there to a distance that they're occupying on the roadway. And then the delay. So this is a delay to those vehicles that are sitting waiting to be serviced. And these are all calculated for each hour within the 24-hour period. You see some highlighting in a couple of those columns. What that highlighting is a reflection of the thresholds within the current policy for allowing or not allowing lane closures. So if a threshold, if the length of the queue is less than 0.75 miles, it would be an allowable lane closure. In the yellow zone, that's kind of a judgment call, where if that queue is sitting between 0.75 and 1.5, the duration that that queue is occurring needs to be evaluated. and if the queue is more than 1.5 miles, then that is not acceptable for any period of time. And the length of queue is then also provided in an output graph, and this is for the end of each of the hour intervals. We are actually looking at 4 different conditions, so the analysis is done with a no lane closure, no diversion, or with lane closure, with diversion, and a combination thereof with lane closures and diversions. So you can actually see the relative impact of the lane closure or the relative impact of with and without diversion. Okay, so we're going to zoom in here on a little bit more of the analysis, which is a total delay, passenger car delay, delay to trucks and buses or large vehicles, and an average delay. These things are calculated for each of the 4 different analysis scenarios. So that's with and without the work zone, with and without the diversion. And this information is actually useful as an input into our road user cost tool, which will be presented in a short bit. So as part of the calibration effort, we went out into the field during the construction seasons of 2013 and 2014 and collected capacity information at 5 different work zones, and the 3rd work zone there in Cuyahoga, we actually had 2 capacity measures. We were there for 1 night, and we saw them close from 3 lanes down to 2 and then down to 1. And that's actually an interesting site to take a quick little look at as well. Within those work zones, we also looked at work activity, and we captured those volumes and the truck percentages. So that's just some summary information to see what was happening. The more interesting part here is what that data told us. So the blue dots on the graph are data that was collected previously in Texas, which is the basis for the base work zone capacity in the Highway Capacity Manual. And the Highway Capacity Manual recommends a base capacity of the 1,600 passenger cars per hour per lane, which is what is in the formulation within the spreadsheet. However, we put in a calibration value because our data in Ohio was actually showing an average capacity among our 6 data collection sites of approximately 1,200 passenger cars per hour per lane. So a little more reduced than what the Texas data was showing us. However, with only 6 points, our confidence that that's the true difference is not great. And I want to bring out that Cuyahoga site. So we looked at Cuyahoga for 2 hours straight. This is a piece on I-77 right at the 480 interchange. And we had a 3-lane reduced down to 2-lane, and we had a capacity at that time at 980 passenger cars per hour per lane. The site then reduced down to a single lane, and we ended up with a capacity of 1,569 passenger cars per hour per lane. So this is the same site on the same night, same environmental conditions, same population drivers, and we have a wide variety of capacity. So I highlight this result to demonstrate the variability within the capacity. And although I recommend that Ohio looks at a reduced capacity in their equation, it needs to be used with an understanding that there is a great variance in that capacity value. And that is tied into the recommendations later on. And I'm going to pass it over now to my colleague, Dr. McAvoy, to talk about our road user cost tool.
All right, so when we look at the road user cost tool, we're trying to capture all of the road user cost elements that have been identified with the Federal Highway Administration within 5 worksheets. The main worksheet that we're going to go into pretty heavily detailed is the RUC input form, and it itself is subdivided into several sections to make it easier for the user to know where to enter information. The RUC output details is very detailed information regarding the output of that work zone that is all generated from the input data. Input options to allow the users to be able to change what options are available. The consumer price index data, which allows us to increase our values for travel time costs for passenger cars or trucks based upon the project year of construction. And then crash cost data, which is generated by the National Safety Council annually for the cost of economic and comprehensive crashes. All right, so when we start with the road user cost input form, we're going to go through each section individually and identify what the user can do and what happens when the user does do certain things. So the first question is trying to identify whether it is a rural or an urban setting. And there's a drop-down box, and I've got all the drop-down menus are kind of highlighted off on the side, so you can see the various options for the different questions. The terrain type, and that is defined via the Highway Capacity Manual for consistency with the queuing tool, and that's either level, rolling, or mountainous terrain. The ADT or the AADT, depending upon what data is collected. I tried to design this so that it could be used on a state level, but it could also be used on a more local level or a county level where they might not have traffic volumes for 365 days a year. They might just have it for a week. So you could either enter ADT or AADT. Maximum truck percentage ranges anywhere from 2.5 up to, I believe, 65. And this is the maximum that you would see on that roadway in any given time period. The speed limit without the work zone. And the next questions all relate to whether or not the free flow speed is known without the work zone. If you do know it, you can just simply type in yes, and then in the GT7 question box, type in the free flow speed value. If you answer no, the box highlighted in black will appear to you, and you will be able to calculate the free flow speed, or the worksheet will actually calculate it for you using the Highway Capacity Manual equation for free flow speed. So for determination of free flow speed, we're looking at the lane width, lateral clearance, number of lanes in one direction, the total ramp density within 3 miles, downstream and upstream of that work zone, and then the spreadsheet will automatically calculate the free flow speed for you. The free flow speed calculations are actually conducted on the output details sheet if you wanted to see the highway capacity correction factors that were being pulled to calculate that. So that's not totally hidden from you, it is still there. Next section is the work zone input data. So now we're entering information specifically on the work zone alone. So the first question is, was the work zone length in miles, as well as the project duration. And this length in miles is going to relate directly to essentially the travel time costs associated between with the work zone, without the work zone, and then that number of days is going to impact the cost for the road users pretty substantially as you go forward. So the longer number of days, probably the higher road user cost will have. How many lanes are close to the project? And then we get into the same thing that we just did with the non-work zone. What is the speed limit? What is the free flow speed? Is it known? Yes or no? And again, if it is not known, we go through the exact same calculation as before, so it's comparing apples to apples. In terms of the free flow speed calculations, this is what is shown on the RUC output detail worksheet. And you can see just like Jacqueline had with the base free flow speed, 75.4 miles an hour. And depending upon whether or not you have a lane width that's less than 12 feet, you would have a correction factor for that. Lateral clearance, anything less than 6 foot, you'll have a correction factor for that. And then the number of lanes and the lateral clearance kind of go hand in hand to come up with a correction factor associated with that element. Ramp density is the number of ramps in that 3 mile upstream, downstream divided by 6, because there's 6 miles total then. And then the equation that is used with the highway capacity software and manual is shown below, so that you can see how those calculations are conducted for both the base project as well as the construction work zone. All right, the third section in the RUC input form deals with diversion information. First question, if there's an acceptable diversion or not. If you answer yes, the entire section for data entry that you see here will be available. If you enter no, you'll see it, the area will become blacked out so that you cannot enter that data. And then that no triggers the calculations for the if statements that are included in the RUC output detail sheet. So if there is an acceptable diversion, we're looking at the length of that diversion route to compare it with the length of the work zone route, as well as the length, compare it with the work zone versus the length of diversion route. What is the average speed? And the average speed can be calculated in one of two ways. We could have several roadways along that diversion route. It may not just be one. And those different roadways, I have up to 6 listed here, could have different speed limits or free flow speeds and or travel time in minutes that you could use with actual information, or you could obviously map it in Bing or in Google Maps to be able to get that information. But the number that will be pulled into the question DIR3, diversion route, question 3, will be the minimum travel time that is shown in either the speed limit or the travel time box at the bottom. So it's going to pull the smallest number there, which would then be the worst case scenario. And then the last question is, what's the estimated percentage of traffic that will utilize the diversion route? We've got a base of 0.1 if you have absolutely no idea. If you have a work zone in an area that you have done in the past and you've been able to fairly well estimate how much traffic is really going to divert, you can obviously change that value. And the more information you have about the city and or area in which your work zone is located is going to really impact the ultimate result of the road user cost document. Next section is all traffic detoured. It can be either yes or no for an answer. And per the request by ODOT earlier on in the project, either we have a diversion with or without a lane closure, or we have a detour route. We simply don't have both. There is capacity within this software to actually do both, to have a detour route as well as a diversion. But if we're taking traffic off the roadway, it would be simply a detour route. What is the detour duration? So the detour duration could actually be different than the construction project duration. If you just want to get them all off the roadway for a bridge installation or something of that nature, that allows that differential to show up here as well. And then the length of the detour route and the average speed are conducted exactly the same way as we did with the diversion route. And we would use again, the slowest speed from the detour route. That would be the conservative estimate for the speed for that route. All right, then we get into our value of time. The current ODOT spreadsheet pulled information from Bureau of Labor Statistics. for the U.S. urban city average. But when we went on the website for the Bureau of Labor Statistics, we found other values of time that might be more appropriate, particularly for Ohio, such as the Midwest urban average. Obviously, a lot of work is done in both in Cleveland, Akron, and Cincinnati, Hamilton. So those were entered as well to give a little bit more fine-tuning to that worksheet. Project year could be anywhere from 2015 through 2025. And then based upon that input for the CPI preference and the project year, the RUC input form will recall information from the CPI data worksheet, which will tell you your passenger car time and your truck time. So that's where the $21.70 and the $58.76 is pulled from. And what I have shown is I have two examples directly below the value of time table, which shows you what is going on with the CPI data form. So we have information that is pulled and estimated from 2015 through 2024, which then corresponds to project years of 2016 and 2025. We're estimating that at a 3% increase. And once that information is known, the spreadsheet could be updated annually to make sure whether or not that is indeed a 3% increase or if it is some other increase. And those are all provided based upon 2014, because that is the last current data that is available on the BLS website. And then the box on the right-hand side of the screen gives you an idea of the differential between the U.S. urban, Midwest urban, Cleveland, Akron, and Cincinnati, Hamilton value of time. While I know when you look at these, you say, boy, there's really not a lot of difference here. But when you take this difference and you multiply it, this is hourly data, multiplied over 60 days or 120 days, it really does start to compound. So that $3 savings that we have between the U.S. urban and the Midwest urban can actually come to quite a lower value of the road user cost that we would have in a worksheet. The next section is associated with the crash cost data. Pretty easy question. Are you going to incorporate crash cost or not? Crash costs are something, for those of you that have knowledge in crash cost, the values can be so high that it can cause a project to absolutely positively be necessary. So some folks like to alleviate those issues and not allow crash cost to be included. So here we give the option, you can include it or you can not include it. If you do decide to include it, then the question is, well, do you want it to be an economic crash analysis or a comprehensive crash analysis? And both of those are pulled off, the National Safety Council information, where the economic cost is essentially everything that we would traditionally think that's associated with crashes, loss of wage and productivity, medical expenses, motor vehicle damage, and then an uninsured cost. The comprehensive costs are substantially different than the economic cost simply because the dollar value that's associated with the value for the loss of the quality of life of an individual if they have a injury state A, so incapacitation, or a fatal crash that really starts to charge those numbers quite substantially. So in the crash cost data worksheet, this is what the information that's provided by the National Safety Council report, and this is what is shown for both the economic and the comprehensive crash cost. And as I said, these numbers kind of get quite charged with the comprehensive crash cost values. So for fatality, we go from 1.5 million all the way up to 4.72 million, so that's quite a differential when we're talking about crash capacities or cost associated with work zones. And what we've done, there have been some previous studies that have looked at crash histories and the crash risk for various types of work zones. So we've taken that overall crash risk and applied it here. So when you have no work zone, you add a work zone, your crash risk increases. It is that differential in increase that we're really worried about here, and so that's what is the multiplying factor to give us the final value in the RUC input form. And then here is the very last section for the road user cost input form. It is actually not an input section, it is the output section, so that everything that you could have, you could just print it off on 1.5 by 11 sheet, and you would have all the information, all the data you entered, as well as all the cost output is on one sheet for you. It is important to note that when running the analysis, if you are going to be changing different types of scenarios, so changing your lane closures, changing your speed limits, this is a scenario-based tool only, so you would have to run a second scenario to capture that additional information. So if you know that you're only going to have 60 mile an hour speed limit in the construction work zone for 10 days, you would have to run that and then run it again for 70 miles an hour for the rest of the 55 days, for instance. But this will tell you all the different elements that are considered a part of road user cost. So we have the travel cost, operating cost, additional time costs that are essentially related to either the diversion. The detour costs are specifically only related to the detour, so those are separated out here. The queue delay cost, it would take the information that we just received and plug that in this column for a total. And then the last piece is that crash cost. The total road user cost and sums all of those individual entities. In terms of the Innovating Contracting Manual, what you can do is take this per day of project. So if you happen to have this project and you didn't know what to charge the contractor for incentives or disincentives, this kind of gives you that idea that you should probably be charging them about $51,000 per day for every time that they are late. So that at least it provides them the appropriate incentive to finish on time, complete the work on time, or they're going to be charged that value every day that they're late. Now when we get to the input options, I did want to take a little bit of time here to go over what the differences are between travel cost and operating cost, because it does show up in the output information in both the output form and the input form. The travel costs are those that are associated with the time duration it takes you to travel. So if it is a diversion, it is the time that it would take, the additional time above and beyond that would normally take you on the roadway without the work zone, that additional travel time on the diversion, the additional travel time that's associated with everyone exiting and detouring, and then the travel time that would be associated with the work zone if, whether or not there was a diversion or a detour, anyone that needs to go through there, if there's a reduction in speed limit, there should be some travel time cost. The operating cost includes both the operation of the roadway, so the maintenance of the roadway, mainly the labor associated with those elements, but it also includes the vehicle operating costs for the individual users as well. And again, that's dependent upon length and duration. And both the travel and the operating costs were generated through the Highway Economical Requirement System, or HERS, for 2015. So these numbers here are the 2015 numbers. When they get multiplied in the road user cost output details sheet, they are converted to the project year that was entered in the RUC input form. All right, so we take a lot of that information that we have in that RUC output section of the RUC input form is directly taken from the last column that says net travel cost per vehicle from the RUC output details worksheet. So all of that information is what we just saw before, but what this does is if you wanted to know specifically what happens with, what is the VMT, this will tell you for the project year what that cost is. And then the next column is the base cost without the presence of the work zone. So if you didn't have a work zone, there are costs that are associated with project travel, project operating. There's a base travel time going through that roadway. So therefore, there are travel time costs for trucks as well as passenger cars. The detour is only if there was a detour. The Q delay would be, again, from the Q worksheet. And then economic crash costs, since we're looking at the differential between the base and the work zone, for the base that is not applicable. And then the cost for the work zone non-diverted traffic. These are the individuals that are traveling through the work zone that are not choosing to divert onto another roadway. The next column is the cost for the diverted or detoured traffic. Here we did not have a detour, and we only had a diversion. But the big thing to note is that none of our truck traffic we're expecting to divert, because it could simply put them on a roadway that is not capable of handling those large vehicles in terms of turning and or speed. And then the total cost due to the presence of the work zone is essentially just the cost for the work zone non-diverted plus the cost of the work zone diverted or detoured, and then the net cost is the work zone cost minus the base cost. And so that's where we come up with the dollar value that's associated with each. And again, the VMT is wholly dependent upon the setting, so urban or rural, the terrain, and the truck percentage that will drive those travel and operating costs. Pretty much everything else is associated with the length of the work zone, those travel costs, the duration, and the traffic volume along that roadway.
So we have one major recommendation coming out of this project, and that is the replacement of QUEWZ and the two existing ODOT spreadsheet tools, which are a queue analysis tool and a road user cost tool, and replace those with these two new tools, which do the capacity analysis and queue analysis and road user cost calculations. To implement that recommendation, it would call for the revision of the two documents that I mentioned at the beginning of the presentation, the first being the traffic engineering manual. So there is a set of procedures in that manual that call for QUEWZ and the current ODOT spreadsheet that would need to be updated to eliminate QUEWZ and use the new queue analysis tool. And then in the innovative contracting manual, again, there are individual procedures for calculating road user costs for projects with no lanes closed, with lanes closed, and detour. Those could all be replaced with our new road user cost tool and a general procedure. Keeping in mind that that tool is scenario-based and would need to be run for each individual MOT scenario. And that wraps it up. More details are in the report. And I guess we're open for questions then.
The leader has unmuted your line.
If anybody on the line has any questions, just hit #6 to unmute your phones, and we're opening it up in the room or on the phone.
I've got two. The works on the road user cost tool. What's that metric from? Lane closure, or is it
We're going to call it the entire repeat.
Oh, I'm sorry. Thank you.
The question was in terms of the road user cost tool, the work zone length. What is that length to? We are calling it length from sign to sign because that is when people start modifying their behaviors. And it is not just at the lane closure. The second question.
The second question is, do the scenarios allow for analysis of roadblocks or lane closures?
So a rolling roadblock for all lane closure, that would be considered a full detour at that point.
Okay, if there's no further questions, you can definitely send your questions to research@dot.ohio.gov, and we will get that to the researchers for answers. Other than that, like I said, the PowerPoint will be available in a couple weeks on our website, or I'm sorry, via YouTube video, but we'll post it. It's also available above the chat pod if you're still on the line. You can download it right there. And thank you for attending.
Thank you.